So this is for Algebra 1. If you have a phone that has an app store, go ahead to that app store. And we are going to search for Google Classroom. And you'll see right here, this is what the app should look like. It's got 2 stars. Awesome. Okay, so I'm going to update mine. Yours, you may already have it from last term. If not, I highly encourage all of you to get it. It's just going to help you stay on track. Doesn't matter how responsible you are, it's always good to have multiple ways to be connected and know what's going on so you don't get behind. So I'm gonna let everybody get that downloaded. Once you have it downloaded and you're ready, show me by having your phone out of your hand sitting on your desk. So I don't want to move ahead until we're all ready. Pause this while we're waiting. And we'll just go through it. So go ahead and open that up. And oh, looks like I haven't even made your class yet. So let's make it. So create class. You don't do this part, but I guess if you're curious, you can just watch the process. So we are Algebra 1. And section, I can't remember what I put for section. Room, this is room 3. Not that that matters. And this is math. Create. So I'm about to have a class code for you guys. And let's see what that is. I'm not super tech savvy. So let me show you this not on your phone. Here's what you're going to do. When you get into the Google Classroom app, you might have some classes that are saved from last term. First of all, does anybody need to get logged in? Does anybody? Yes.
I need to get logged in.
Okay, you need to get logged in. So let me log out and see what that screen's going to look like. I did it. Is that it? Anybody know how to log out on here?
It's the profile picture at the top right, and then you need to add another account.
Oh, okay, beautiful. Thank you. Okay, so the account that you want to use is your Excel Center email. And your Excel Center email is going to be, let me get a note written down. Let's move this. So my name is Taylor Gable. So my email is going to be my first initial and my last name. So it will look like this. T Gable. Yours will be the same, but with your first initial and last name. At Goodwill Educates .org. And then the password that you have, if you haven't logged into this email before, I believe the temporary password is going to be capital E, and then it's just the word educates. Okay, that E is capital. So this should be the email and password to get in. I'm gonna let you guys try and get logged in first. I'll pause this as well. So whenever you are in the app, finally, at the bottom right-hand corner, there's a little plus sign. You'll click that, and you'll have 2 options, join class or create class. I'm actually not sure if you guys have the create class option. Okay, so you'll hit join class, and this is where you type this code in. And I should be able to monitor on my end with all this signed up. So let me check on that. Okay, so everybody's in, is that correct? So every day that we have a lesson, Monday, Tuesday, Wednesday, Thursday, it will be posted into this classroom. Right now it looks very empty because it is empty. But if you want to see kind of an example of what it might look like, whenever you come through, you'll see something like this, day 24 live notes, and it'll give you a little description of what we talked about. I'll always put a picture of your homework assignment so that you can look on there. There's just an example. Okay. They're all going to be pretty homemade looking. Um, I like pencil and paper. I think that it's easier to do math on paper than on a computer. So we try to do it that way in here. And then you'll also see a YouTube link on every post. And that YouTube link is going to be taking you to, let's see, I guess it didn't work. Maybe because it's old. Shady. Gotta put it on the right account. Switch account. So it should take you to my YouTube page, Taylor Teaches Math Excel. And in here, you'll be able to see all of the lessons. So if you're curious about other classes, you can technically watch them too, if you're just bored. But you'll notice that these videos are going to have the full lesson that is taught. So you won't ever miss anything as long as you're connected on Classroom. Any questions about that? Does everybody understand what to do if you miss a day of class? Basically, let's say you're sick one day and you are not able to make it to school. I don't want you to come here when you're sick. Don't get everybody else sick. Also, you should be resting. I want you to take care of yourself. If you are sick and you miss a day of class, don't be stressed. You can watch that lesson. It will be posted. The only issue with this, the way that we do things in here, is if you do miss that day, my expectation for you is that you will go back and watch that lesson if the assignment doesn't make sense to you. I'm not going to reteach a whole lesson that I already taught. That's what the videos are for, so you can go back and do that. Now, after you've watched the video, ask away. I'm happy to help, always. But I'm not going to do double the work because you don't want to do the work. It's available to you. Use it. Okay? All right. So, getting out of that. And let's transition to some math things. Move this over. And here is what we start every single day with. Now, today was a big day of talking about all the procedures, policies, expectations. But every day that you come in from tomorrow and until the end of the term, you will see a do now assignment on the board. So these assignments are participation grades. I'm not going to be checking your answers at all. You try, you do it, you fill it out, you get all your points. It is super simple. So what we're doing here is I just want to see what you know. I want you to try to solve each of these equations below for the value of x. Do your best. If you have no idea what to do and you're totally lost, the do now is not the time to ask questions, because what will happen is I'm going to set, I usually give you about a 10-15 minute timer for you guys to work independently by yourself, quietly, doing these on your own. After the timer goes off, we will go through all the answers and we'll explain in detail how to solve everything, how to do it. And that is your time to ask as many questions as you need. One thing I want to encourage again is asking questions. Please don't ever leave this room confused. If you don't get it, tell me. I can't read your minds. If you're totally lost, I won't be frustrated with you. Okay. I'll be frustrated if we go 3 weeks and you're totally lost because you won't tell me. I want to help you guys. Okay. If you don't get it, let me know. I won't be frustrated. So I'm going to have this posted up here. You guys are gonna I'm gonna set a 15-minute timer. If you finish early, do whatever you like with the rest of that time. And we will go over these together once that timer goes off. So I'm gonna pause this recording and start the timer now. So for these do now problems, how did you guys feel solving them? You feel like you know how to do it, or is it like I'm so lost I don't even know where to begin?
Say 3 and 6 was probably not really good.
3 and 6 were a little difficult. Maybe all of them were a little difficult, and that's okay. That's okay. Let's do them all together, and we're gonna go real slow, step by step. If I write something and you don't know why I wrote it, please stop me. You're not gonna make me upset. I want you to understand. You should not ever leave this room confused. Okay? Get out. Okay, so let's focus on number 1. And if you have anything written incorrectly on your paper, I encourage you to correct it so that you can look back and see how to do it right. So I have an equation that says x plus 2 is equal to 4. First of all, who can tell me what does this x mean? Yes.
Doesn't it basically mean 1?
It could mean 1 but if I put 1 here, if 1 plus 2, if I add those together, I would get 3. And that's not equal to 4. X is, whenever we're working with variables and we have an x by itself, you are correct in saying that we assume it's 1. But in this case, we're trying to solve for x. We're going to figure out what number x is. Whenever we see a letter in math, we call that a variable. Everybody say variable. I know it, guys. A variable is just a symbol, a letter that is standing for a number that we don't know yet. So we need to solve and figure out what number do I put for x that when I add plus 2, I get 4.
2.
2. I know 2 plus 2 equals 4. Beautiful. 2 plus 2 is 4. So let me show you the way that we would do this without just knowing that 2 plus 2 is 4. Whenever we are trying to solve for x, for that missing number, we want to get rid of everything on this side of the equal side that is not x. So I'm going to split this in half. Okay, that equal sign is the divider. We have the left side and we have the right side. So if I have x plus 2, to get rid of plus 2, what would we do? Subtract 2. We always want to do the opposite. So instead of plus 2, I'm going to write minus 2. And what else do I need to do? On the other side of this equal sign, we need to do whatever we do on one side, we have to do it to the other as well. So minus 2 on both sides. And then I like to draw a line under that. So first of all, when we have plus 2 and minus 2, what happens to this 2 here?
Yes,
It cancels out. Positive 2 minus 2 gives us 0. So because it cancels out, we just cross it off. It disappears. And what's 4 minus 2? 2. So now we've gotten rid of that plus 2, and we just need to bring everything else down. I'm going to bring x down. I'm going to bring my equal sign down. And I did 4 minus 2 to get 2. And this is your answer. X equals 2. Which is what we figured out right there at the beginning. 2 plus 2 is 4.
See, I did it differently. I took the one with me
Yeah.
for some reason. I got the same answer, but
So how'd you do it?
I did the -2 on both sides, and then I brought down the 1x. Obviously, it's just not there, but it's
Right.
there. And then I just divided it, and I still got 2.
Perfect. Yes, you could do that. So I'm going to write out what you said so that it makes sense. Sometimes it helps to see it. Basically what Marquila was saying is that she put a 1 next to the x. So it was like 1x plus 2 equals 4. She still subtracted 2 from both sides and just brought down 1x equals 2. And to get rid of that 1, what this means is 1 times x. She divided by 1 on both sides. And then we get x equals, well, 2 divided by 1 it's still 2. So this is correct. It is adding an extra step, but it's not incorrect. It's totally right. So perfect. Hello. Let me pause this. Before we go to the next one, does anybody have any questions about number 1? Does everybody understand it? Feel good about it? Beautiful. Okay, let's look at number 2. Now I have an equation that says 12 is equal to 3x. Now, what does this mean when I have a number right beside a variable? Does anybody know what's happening here?
No, but I know you have to get rid of it.
You do have to get rid of it. That's correct.
You divide 12 by 3.
Yes, you would be dividing 12 by 3. Now, why are we dividing by 3?
Because it's the variable beside it.
Yes. Okay. So let's talk about operations. So in math, we have operations, which is just a fancy word for the things you can do to numbers: adding, subtracting, multiplying, dividing. Okay. So something we'll talk about more in depth later on is what we call inverse operations. We'll take notes on it later, so don't worry about holding these words in your head yet. But whenever we have 3x or any number next to a letter in math, what's happening is we are multiplying 3 times whatever this number is for x.
4.
Oh, yes, it would be 4. Good. So whenever we are trying to get rid of a number and get x by itself, like we did in the other problem, we want to do the opposite always. So right here we had plus 2, so we did minus 2, because minus is the opposite of plus. So if we have 3 times x, the opposite of multiplication would be what? Division. Good. So here's how we would write that. We want to divide by 3 on this side. And whatever we do to one side, we have to do to the other. So we're also going to take 12 divided by 3. And we're going to draw a line. Does everybody understand up to this point so far? Awesome. Okay. So over here where we divided by 3, what happens to my 3's? They cancel out. Good. So 3 divided by 3 is 1. So what we really have is just like what you said in the last problem, Markula, that 1x, we would have 1x, but we could just write x. It just cancels it. So now we have x by itself. What do I do next?
By 12 by 3.
Take 12 divided by
Yeah, what's 12 divided by 3?
4.
4. Good. And then we bring down the equal sign. If you just write 4 and then a space and x, that's not correct. You need your equal sign. So circle your answer. That is it. X is 4. And we know that it's correct because 3 times 4 is 12. Any questions about number 2? Everybody feel good about it? Well, good. Okay. How about number 3?
Would that be 9?
9. Let's see. 9 over 4. 9 divided by 4.
No, no.
It won't be 9. It would be if this was x minus 4.
Isn't it 1?
It's 1. 1 divided by 4.
We're gonna times it. We're gonna times the
No,
4
I mean-
on both sides.
Okay.
Sorry.
We are. What were you
That's
saying though?
Okay.
No, go ahead. I want to hear what you were saying. Something about 1.
How I did it, I basically subtracted 4 from both sides.
Okay, so you subtracted 4. So if we had x plus 4, we could subtract 4 to get rid of it. But right here we have x over 4, which, does anybody know what operation this is? Are we multiplying? Are we dividing? Are we adding? Are we subtracting?
That division?
This is division, yes. Anytime you have a line separating things, you're dividing them. So we have what number divided by 4 equals 5?
So is that 20?
It will be 20, that's right. So let's solve it using our opposite operations. If we want to get rid of 4, okay, we want to cancel it out by doing the opposite. We're starting with division. What's the opposite of division? Multiplication, multiply. So here's how we could write this. You could either write times 4, or what I really like to do is put it in parentheses and 4. That means I'm multiplying by 4. So I'm multiplying this side of my equation by 4. Where else do I need to multiply by 4?
On the other side?
On the other side. Perfect. Okay. So what happens to my 4s over here?
You gotta cancel them out.
Cancel them out. Good. Which is going to leave x all by itself. And what else do I do?
Take another 4 on the other side.
So you got a 4 over here. What am I doing with this 4 and this 5?
Multiplying.
Multiplying. Good. If it helps to write that little multiplication symbol, do it. Absolutely. But anytime you see a number with parentheses, we are multiplying like this. So what is 5 times 4?
20.
20. And if you can't do that in your head, there are calculators on your tables. Please feel free to use them at any time. So we have 5 times 4 is 20. So what am I missing? The equal sign. Good. X equals 20. Circle that. That's our answer. And we know this is correct because if I replace my x with the number 20, I can double check my work. I can say 20 divided by 4 is equal to 5. So here, I'll show you on the calculator. 20 divided by 4, it equals 5. So we are correct. Any questions about number 3? Everybody feels good about it. Good. Okay, can we go to number 4? Okay, number 4. My equation is 7 is equal to x minus 6. What should I do here?
I'm sure I got it wrong, but what you added?
That's not wrong. Yes, you add.
No,
What?
I actually subtracted it. That's all. But I'm getting down. Now I'm getting it.
Okay, that's okay. That's okay. So you caught your mistake. That means you're learning. That's amazing. So because we want to get x by itself, remember that's the goal always. We want to get x by itself. That means we got to get rid of whatever is on the other side with x. So we have minus 6. How do I get rid of that?
Yes.
We add 6. Good. We're just doing the opposite. And where else do I have to add 6?
On the box letter?
Yes, by the 7. We have to do whatever we do on one side, we have to do it to the other. So we've added 6 to both sides. What happens to my minus 6 plus 6?
Cancel out.
They cancel out. They're gone. And what do I do next?
You add 7 plus 6.
Yeah, what's 7 plus 6?
13.
13. And
Equals X.
13 equals X. Perfect. Remember, if you want to check your answer, make sure you got it right. You're just going to put the number you found and replace it with X in that original equation. 13 minus 6 is 7. So we got it right. Any questions about number 4? Okay. We ready for 5 and 6? These are the tricky ones, okay? So, don't beat yourself up if you got any of them wrong in general, but especially number 5 and 6. Numbers 1 through 4 are what we call one-step equations. You just have to do one thing and you've solved it.
Do you have one extra chair?
I do.
Or for one period?
I have a couple of extra chairs. Here, actually, you just passed them right there. Yes, you're welcome. Okay, so
Two-step equation.
yes, they are two-step equations. And we're gonna go in lots of detail. So if you, after we go through 5 and 6, are still totally lost, don't be worried. We will have so much time to go over these. So number 5. Now we have more stuff going on here. So let's think about this. I have 5x, 5 times x, plus 3 equals 18.
What did you subtract 3?
Yes. Yes. Oh my gosh. Okay. So whenever we have two different operations happening, that means we have multiple things happening with the numbers. We have a plus 3 and we have 5 times x. We want to get rid of addition and subtraction first, always. We're getting rid of that first. So I forget who said it. Was it you, Markayla?
Yeah.
Okay. We're going to subtract 3 from both sides first.
Three's canceled.
Yes.
15.
Perfect. My 3's are going to cancel out. And then I'm going to do 18 minus 3, which is 15.
Bring down the 5x equal 15. Divide by 5.
Yes. So in the previous problems, we do the one thing like we just did, and then we can bring our x down. That's the answer. Well, is x by itself yet?
No.
No. So we still need to bring down whatever's left, which is 5x. And our equal sign. So 5x equals 15. All right, guys. So we just subtracted 3 from both sides. And that left us with 5x equals 15. So now I want you to think of this as a whole new equation. That has disappeared. What's above is gone. Now I just have 5 times x equals 15. What would I do to solve for x here?
Divided.
Yes, the opposite of multiplication is division. So we're going to divide by 5. Where else should I do this? On the 15, other side of the equal sign. Perfect. Okay. Everybody understand up to this point? Any questions? Cool. So from here, what happens?
5x just turns into an x.
Yes, my 5's cancel. Now I just have x.
15 divided by 5 is 3.
Perfect. 15 divided by 5 is 3. What am I missing? The equal sign. That is so important. You don't put that on there. You're not writing something that's real. X is equal to 3. Beautiful. Hey, any questions on that? Yes. Oh, I thought you were raising your hand. No big deal. Okay. And if we wanted to check our answer, we could do that with this one too. Put a little sticky note up here and we'll go through how to check. I'm just going to replace x in my original equation with the number 3 we found. So 5, and instead of x, I'm going to write in parentheses 3. This means 5 times 3, okay? Anytime you see a number in parentheses directly next to another number, we're multiplying. So 5 times 3, 5 times x, plus 3 equals 18. And I sure hope it equals 18, because that would mean we got it right. So let's see, what's 5 times 3? 15 plus 3
Equals 18.
equals 18. 15 plus 3 is 18. So we know we got the right answer. Awesome. Okay. Number 6.
That's 7.
Say it one more time.
7.
7. Like for the answer?
X.
For x? It could be. I haven't solved it yet, so I'm not sure. What do I do first to solve it?
Subtract 6 from both sides.
Yeah, yes, good. We want to get rid of addition and subtraction first. So we have plus 6 on this side. We're going to subtract 6 from both sides. Minus 6. Minus 6.
The 6's cancel out.
Yes, my 6's will cancel out. And what should I do now?
21 minus 6 is 15.
Good. 21 minus 6 is 15.
Equal x over 3.
Good. Then we want to bring everything down. I've got 15 equals x over 3, or x divided by 3. Okay. So again, just like last time, pretend that the top half is gone. You have a whole new equation. 15 equals x divided by 3. What number divided by 3 gives us 15? So how am I going to figure this out? What do I do to get x by itself?
Times it by.
Yes, we have division here. We'll do the opposite. We're going to multiply by 3. So multiply by 3 on this side. And where else do I do this? On the 15. Good. We're going to multiply both sides by 3. So what happens over here on the side with my variable, with my x?
3's cancel.
Yes, my 3's will cancel out, or gone, and that's going to leave me with x by itself now. What else do I do?
3 times 15.
3 times 15. If you need your calculator for that, feel free to use it.
45.
45. Good. And what am I missing?
The equal sign.
The equal sign. Good. So in this case, our missing number x, our variable, x is equal to 45. You want to check your answer? Make sure we got it right? Big number compared to the rest. Let's check it together. So, how would I check my answer? Does anybody want to explain that to me?
Plug 45 into where x was.
Yes, we're just going to use the same equation that we started with, but instead of x, we're going to write the number we found, 45. So 21 equals x over 3. Instead of x, we'll write 45 over 3 plus 6. Okay, so 45 divided by 3 plus 6 should be equal to 21. So first off, what is 45 divided by 3? 15. Good. And now we just do 15 plus 6, and that is 21. That's exactly what we wanted, so we did it right. Awesome. That makes sense to everybody. Good. Good. Okay, so this is what our lesson is going to be over today. These 3 things. First of all, we're going to talk about what a variable is. We already touched on that a little bit in our activity. The next thing we'll talk about is something called inverse operations. We touched on it a little bit, whether you realize it or not, but we'll go in more depth. We'll talk about the order that we do operations in. And then we're just gonna do a little more of what we just did, solving 1-step and 2-step equations. So, little chill, relaxing first day. We're not gonna get too crazy just yet. So if you are someone that likes to write the topics down, you're welcome to do that. I'm happy to give you time for it. I'll wait a minute while everybody gets things out and ready. We're about to start our first page of notes. Let's get started. So I am gonna tear this out, and I guess that was the last page of that notebook. So I'm gonna get a new one. So here is what I'm going to title my notes. I am notorious for losing everything. So if I don't title it, I will not know what it was from. You don't have to title your notes, but I'm going to. So this is, let's see, Algebra 1. And this is the beginning of Unit 1. Unit 1 note. Unit 1 is all about equations and inequalities. We're not going to talk about inequalities today, but just know that that is part of Unit 1, inequalities. And then, so, page numbers, this will be page 1. And this is day 1 notes.
Hello. How are you?
All right, so one more thing. I'm going to write day 1 notes. Okay. So, let's start with just defining a few of the words that you're going to hear me say a whole lot in here. The first word that we're going to talk about is variable. Again, we already touched on it a little bit, but let's just have a definition written down. So, variable. And can somebody tell me again, what's a variable? Do you remember what a variable is?
Let's see, number.
A missing number, yes. It's basically that X that you see in most equations. It's a letter that stands for a number we don't know. So let's say a letter like X stands for a number we don't know. So anytime you see X in an equation, just like we saw in the do now problems, it just means we don't know what that number is and we need to solve for it. So let's talk about operations. Question that I will ask you a lot in here when we solve equations is I'll say, what operation are we using? So operations, remember, are just the things that we can do to numbers. And let's make a little list. So first we have, I'm going to color code this list. We have addition, Addition, what's the opposite of addition? Subtraction. Good, so I'm gonna make a little opposite of it. Addition is the opposite of subtraction. If I'm having trouble seeing words or reading my handwriting, you won't offend me. Just tell me to zoom in. Okay, addition and subtraction. The other operation we're gonna focus on is multiplication. Which, okay, let's talk about this for a second. I need to get out of the habit of drawing this X for multiplication. I think it is ridiculous that this is the multiplication symbol we are taught. Because it makes it so confusing when we introduce variables. Because you see an X and it's like, is that a multiplication sign or is it a letter? I will never write multiplication with an X. It will always be number in parentheses next to each other.
Can it also be a decimal?
Like the dot. Yes, another way that you can write multiplication, just putting a dot. A dot can be your multiplication symbol. So let's write multiplication. And what is the opposite of multiplication? Division. Good. So there are actually more operations than this. There's more things we can do to numbers than just these four things. However, for what we are doing, this is all we need to focus on right now. So knowing that these are the opposites of each other is kind of the main detail that we're going to use to be solving equations. So an equation is just a number statement with equal sign inside of it at some point. Equation, equal sign, it sounds kind of similar. So let's talk about what we do when we are solving a one-step equation. So I'm going to write a little title down here. I say solving a one-step equation. I'm going to give an example to help us with solving, or to help us with kind of writing a guide out that we can reference if we ever forget what to do. Let's write x plus 7 equals so we're going to write our little step-by-step guide. Whenever we have an equation like this, what is kind of the first thing we want to think about? What are we going to do first?
How to get rid of the 7.
Get rid of the 7. How did you know that we needed to get rid of the 7 instead of 12?
I need X by itself.
We want to get x by itself. Yes. Yes. So getting rid of 7 is absolutely correct. Let's write our goal out to the side. Our goal is always to get the variable x by itself. So if I were to get rid of 12, for example, if I subtracted 12 from both sides, that doesn't help me get x by itself. It just puts more stuff over there with x. We want this to be the only thing, x, on this side of the equal sign. So we're gonna use what we call inverse operations. Okay, does anybody know what inverse means?
The opposite.
The opposite. Good. So what we're going to do is we are going to get x by itself using inverse operations. Inverse just means opposite. So in this case, we have plus 7. The inverse operation of plus 7 would be minus 7. Minus 7 on both sides. So we have subtracted 7 from both sides. What happens next? Cross out the 7s. They cancel out. What now?
Subtract.
Yeah.
Minus 7.
12 minus 7 is
5.
5. It's 5 over here.
X equals.
Good. Now we're going to bring everything down. Bring down x equals 5. X equals 5. Here we go. So this was a one-step equation because we only had to do one step. We subtracted 7 from both sides. That was it. We got our answer. Now, a two-step equation is when we have more than one operation happening to our variable. And we did some examples of that in our do now, but let's talk a little more in depth about how we know what to do first. Before we go on to that though, does anybody have any questions, hesitations, confusions about the one-step equations? None at all? Okay, beautiful. Love that. So now let's talk about the solving. A two. Yeah. Example I will give is, let's see, 3x minus 2. So, is our goal changing at all? No, we still want to get the variable x by itself. Sometimes it helps to circle it, just identify where it is. And whatever side of the equation x is on, that's going to be the side that we move stuff over from. We're trying to get that by itself. So, other than x, on this side of the equal sign, you can see we've got two numbers. We've got a 3, we've got a minus 2. We got to get rid of both of those. But we also got to know which one do we get rid of first. So I'm going to give you a little guide for knowing that. For a two-step equation, step 1 is to cancel any addition or subtraction. So get rid of it. Cancel addition or subtraction first. You have to do it first. If I get rid of multiplication and division first, I'm not going to get the right answer. You can try that. You'll see you'll get a very different number. So let's check and see, do we have any addition or subtraction? We do. We have a -2 here. So what am I going to do to get rid of -2? 2 to both sides. Very good. So +2. Okay. We know we're canceling. -2 + 2, they cancel. They're gone. Okay. Now what am I going to do next?
Gonna bring the 3x down.
Yes, we're going to bring everything down. 3x is still left. We didn't get rid of the 3, so that comes down. We've got 3 times x. My 2's gone. What else do I bring down?
12.
Yes, 10 + 2 is 12.
And the equal sign.
And the equal sign. Don't forget the equal sign. Okay.
We just do the opposite.
Yeah, now same thing. We're going to keep doing the opposite. So what is the opposite of what? First of all, what operation is happening here? 3 and x.
You're timesing, so you're gonna divide.
Yes. We are multiplying. We're timesing. 3 times x. To get rid of the 3, we do the opposite. So first we cancel out all addition and subtraction. We know there's none left. So we can move on to the next step. Step 2 is to cancel multiplication and division. So just like you guys said, we have 3 times x. We want to get rid of the 3, get x by
Divide it.
itself. Yes, you divide it by 3. Where else do I divide by 3?
Well,
12. Good, we do it on both sides, always. I draw my line. And what happens from here?
x equals 4.
Yes, my 3's cancel, which leaves me with x by itself. I'll go ahead and bring down my equal sign. And what is 12 divided by 3? I know you just said it. 12 divided by 3.
4.
4. Good. X is equal to 4. Now, it can get more difficult than this. Sometimes there's 3 step, 4 step, 5 step, 6 step. We're only going to talk about 1 and 2 step today. I really just want to kind of dip our toes in and get just a little bit of math going. How do we feel about these 2 topics today? Feel decent? You guys feel like you could do it on your own if I asked you to? Even if you don't, we're going to do this again tomorrow, a little more of it. So don't be worried at all if you're a little confused. I think we're going to actually just end it there, you guys. You've done a really nice job today. I appreciate y'all being so respectful, listening, following directions. No math-related exit ticket today, but you need to turn this in. This is your exit ticket. This math classroom agreement. Please write any scheduling conflicts you have. If there's days you can't be here, let me know. Any other information, sign it, date it, put it in the turn-in bin at the front of the room by Friday. It is for a grade. Okay? All right. That is it, you guys. I hope you enjoy your lunch. I'm going to let you go a little early. And I will see you tomorrow.
See you tomorrow.
This will be posted on Google Classroom. You guys will see that in probably an hour or two.